I am Dr. D. Prince Sudherson, Associate Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. Today, I am going to discuss about the subject chain drive design, which comes under the subject design of transmission system, subject code ME 8651. Before we deal inside the subject, we can see about the course outcome. After successful completion of the course, the students should be able to analyze the concept of design in the flexible drive elements like belt, chain, and rope drives. The student should be able to develop a method of various types of gears with parallel axis. The student should be able to develop methods of various types of gears with inclination with axis. The student should be able to explain the techniques used in industrial design, multi-speed gearbox application. The student should be able to categorize the suitable design for cam, clutches, and brakes for automotive application. Chain drive design. Introduction to chain drive. Chain drive is a way of transmitting mechanical power from one place to another. It is often used to convey power to the wheels of a vehicle, particularly bicycles and motorcycles. It is also used to a wide variety of machines beside vehicles. Most often, the power is conveyed by the roller chain known as a drive chain or transmission chain passing over a sprocket gear with the teeth of the gear messing with the holes in the links of the chain. Belt and rope drives that slipping may occur. In order to avoid slipping, steel chains are used. The chains are made up the number of rigid links which are hinged together by pin joints in order to provide the necessary flexibility for wrapping round the driven and driving and driven wheels. These wheels have projecting teeth of special profile and fit into the corresponding recesses in the link of the chain as zone. The teeth wheels are known as sprocket wheels or simply sprockets. The chain may also be used for long center distance up to 8 meters. The chain are used for velocities up to 20 meters per second and power up to 1 ton kilowatt. This is a chain drive, hinged chain link. Smaller sprocket is known as pinion. Larger sprocket is known as gear. High center, chain roller, sprocket. These are the parameters. Advantage and disadvantage of chain drive over belt and rope drives. Advantage. As no slip takes place during chain drive, hence perfect velocity ratio is obtained. Since the chains are made of metal, therefore they occupy less space in width than the belt or rope drives. It may be used for both long as well as short distance. It gives the high transmission efficiency up to 98%. It gives less load on the shaft. It has the ability to transmit motion to several shafts by one chain only. It transmits more power than belts. It permits high speed ratio 8 to 10 in one step. It can be operated under adverse temperature and atmospheric condition. Disadvantage. The production cost of chains is relatively high. The chain drive needs accurate mounting and careful maintenance, particularly lubrication and slack adjustment. The chain drive has velocity fluctuation, especially when underly stretch head. Classification of chains. The chains on the basis their uses are classified in the following three groups: hoisting chains, conveyor chains, power transmitting chains. So the figure shows hoisting chains, chain with overlinks, chain with square links. So terrible hook joint type chain, closed joint type, then simplex type, duplex type, triplex type. So number of teeth on the smaller or driving sprocket or pinion. The linear velocity of the sprocket is not uniform but varies from maximum to minimum during every cycle of tooth engagement. This result in fluctuating in chain transmission and may be minimized by reducing the angle theta or by increasing the number of teeth on the sprocket. It has been observed that for a sprocket having 11 teeth, the various speed in 4% and the sprocket having 17 teeth and 24 teeth, The variation of speed is 1.6% and 1% respectively. In order to having a smooth operation, the minimum number of teeth on the smaller sprocket or pinion may be taken as must be 17 for moderate speed in the 21 for high speed. The following table has shown the number of teeth on the smaller sprocket for different velocity ratios. Design procedure of chain drive. The chain drive is designed as discussed below. First of all, determine the velocity ratio of the chain drive. Select the minimum number of teeth on the smaller sprocket or pinion from the table. Find the number of teeth on the larger sprocket. Determine the design power by using service factor, such as choose the type of chain, number of strands for the design power in RPM of the smaller sprocket. Note down the parameters of the chain, such as pitch, roller diameter, minimum width of the roller. Find pitch circle diameter and pitch line velocity of the smaller sprocket. Determine the load W on the chain by using following relation. Calculate the factor of safety by dividing the braking load to the load on the chain. This value of factor of safety should be greater than the value. Fix the center distance between the sprocket. Determine the length of the chain. The other dimension may be fixed as given. Example problem. Design a chain drive to actuate a compressor from 15 kilowatt electric motor running at 1000 RPM. The compressor speed being 350 RPM. The minimum center distance is 500 mm. The compressor operates 16 hours per day. The chain tension may be adjusted by shifting the motor on slides. Given data: power 15 kilowatt, N1 1000 RPM, N2 350 RPM. We know that the velocity ratio of the chain drive N1 by N2 from equating the values we will get 2.86 round of 3. From table 21.5 we find out for the roller chain the number of teeth on the smaller sprocket or pinion T1, number of teeth on the largest sprocket or gear T2 equal to T1 into N1 by N2 equal to 25 into 1000 divided by 350 equal to 71.5, say 72. We know that the design power equal to rated power into service factor. The service factor Ks is the product of the various factors K1 into K2 into K3. The values of these factors as follows: load factor K1 for variable load with heavy shock equal to 1.5. Lubrication factor K2 for drop lubrication as 1. Rating factor K3 for 16 hours per day equal to 1.25. Now service factor K is equal to K1 into K2 into K3, 1.5 into 1 into 1.25, 1.875, and design power 15 into 1.875 equal to 28.125 kilowatt. We find out the corresponding to a pinion speed of 1000 RPM. The power transmitted over the chain number 12 is 15.65 kilowatt per strand. Therefore, a chain number 12 with these two strands can be used to transmit a record power. From the data book, we find out pitch P equal to 19.05, roller diameter small d 12.07, minimum width roller W equal to 11.68, braking load WB equal to 59 kilonewton. We know that the pitch circle diameter of smaller sprocket D1 equal to P into cosecant 180 divided by Ti equal to 0.152 meter, and pitch circle diameter of the largest sprocket per gear D2 equal to 0.172 meter. Pitch line velocity of the smaller sprocket V1 equal to pi d N1 divided by 60 equal to 7.96 meter per second. Load on the chain W equal to rated power divided by pitch line velocity equal to 1844 Newton. Factor of safety equal to WB divided by W equal to 32. This value is more than the value given in the data book, which equals to question 11. The minimum center distance between the smaller and larger sprocket should be 30 to 50 times the pitch line. Let us take as 30 times the pitch. Center distance between the sprocket equal to 30 into P. So 30 into 19.05 equal to 572 mm. In order to accommodate initial shag in the chain, the value of center distance is reduced by 2 to 5 times. Corrected center distance x equal to 572 minus 4 equal to 568 mm. We know that the number of chain in links k equal to t1 plus t2 divided by 2 into 2x divided by p plus t2 square minus t1 divided by 2 by the whole power square into p divided by x equal to 110. Length of the chain L equal to kp, k into p equal to 110 into 19.05 equal to 2096 mm equal to 2.096 meter. These data referred by the mentioned books: Machine Design Volume 2, Design of Transmission System by Jalaluddin, Machine Design R.S. Kurmi and J.S. Gupta, Design of Transmission System by T.J. Prabhu, Design of Transmission System by V. J. Kumar. Thank you.